It's crucial to remember that Betelgeuse is in the past because the light we see is more than 600 years old. It's possible that the star has already burst, but this is not confirmed. The scientific community was taken aback in 1987 when a blue star burst, demonstrating that our preconceptions can be tested. We can gain a better understanding of the situation and anticipate certain surprises by studying Betelgeuse and other large stars. The current behavior of Betelgeuse, with its cycle between flaring and fading, provides intriguing physical details. It's brighter than predicted, but hopefully it will return to a 400-day cycle. But there's also a chance that Betelgeuse will blow up sooner than scientists had thought. A new study casts doubt on our understanding of Betelgeuse's evolution. It implies that Betelgeuse is approaching the end of a carbon-to-heavier element conversion process, which includes magnesium and oxygen. This contradicts our previous belief that Betelgeuse is now burning helium. Researchers believe that Betelgeuse's core may collapse in a few decades when it has used up most of its carbon, resulting in a massive explosion known as a supernova. However, we should proceed with caution as it is difficult to determine Betelgeuse's exact stage. According to the study, Betelgeuse is a plausible candidate for the next major supernova as the core collapse is expected to occur a few decades after the carbon is gone. The precise date when the carbon will run out is unknown, though. It will only take a few decades for the star to burst once it does. It is difficult to predict, though, whether we will be around to see it, as the carbon-burning phase can extend for millennia. Also keep in mind that the results of this study may vary as it has not yet been published. Just think of how incredible it would be if Betelgeuse really went supernova. How may it appear from Earth? It would be simply amazing. Betelgeuse's explosion will be extraordinarily bright because it will occur far closer than the last supernova we witnessed in the Milky Way, which was in 1604. About 548 light-years separate us from it. Even the ancient Egyptians described a second sun in the sky and alluded to a potential explosion. The last explosion of Betelgeuse will be a breathtaking sight. Initially, there will be faint indications of the impending supernova. Detectors will pick up neutrino particles when they arrive on Earth. Next, the high-energy photons escaping from the exploding star will signal the start of the main display. Just your eyes will do. No additional equipment is required. In a few days, the star will become brighter still, brighter than Venus. In a week, the brightness will increase by 10,000 to 100,000 times. There will be nothing brighter in the sky than Betelgeuse. The remnants of a strong explosion can have a brightness comparable to that of a half or quarter of a full moon. Concentrating all of its brilliance into one single point, this brightness is noticeable even during the day and creates dramatic shadows at night. Venus, the second brightest object in the night sky at the moment, will not compare to the brightness of Betelgeuse's explosion. Imagine the breathtaking scene. This will be a magnificent explosion that can be seen for a long while, roughly 100 days. This will be a rare chance for astronomers to witness the aftermath and uncover unexpected information. Soon after, the star will gradually lose its brightness over hundreds of days until it vanishes. But don't worry, we can view it for a very long time using binoculars and telescopes. Humans won't be harmed by Betelgeuse's supernova because it is far away. Such incidents in the past produced observable sky changes that were frequently interpreted as bad omens. There would undoubtedly be conversations and interest in this supernova everywhere. Brian Pinkers, an astronomer, thinks it might spark a widespread interest in astronomy. But we shouldn't anticipate a bomb-like detonation. Prior to the major event, there may be lesser eruptions or warning indications. It's crucial to remember that our galaxy has other red supergiants besides Betelgeuse. Eta Carinae and other stars may explode before it. According to statistics, a supernova should occur in our Milky Way once every 50 years. We haven't seen one in the last 400 years, which is surprising, but we have seen the traces of previous explosions. According to statistics, an exceptional cosmic event is due soon. It's only a matter of time until the next big star steals the show. The Great Dimming was a notable occurrence that occurred there in 2019. Rather than brightening and fading as expected, the star's brightness dropped sharply. This baffled astronomers, and more study was required to fully comprehend it. It is easily visible from backyards by skywatchers, who can provide insightful observations. However, Observatories like the Hubble are used by scientists to obtain a deeper understanding of the star. When Betelgeuse's brightness abruptly dropped, there were rumors of a possible supernova. Since it would be the closest supernova ever seen, this thrilled them. This supergiant star, in contrast to our Sun, is much more likely to have a supernova and turn into a neutron star or black hole. Some experts did, however, advise against drawing hasty conclusions. They proposed that common causes such as a passing cloud of dust or a cold area could be the cause of the dimming. The Paris Observatory's astronomer Miguel Montarge and his colleagues provided an explanation for the star's fading. In order to obtain clear photographs of Betelgeuse in 2019 and 2020, they put out two possible explanations for this phenomenon and made use of a specialized telescope in Chile. These photos revealed the causes of the star's decreasing brightness. The dimming was most likely caused by internal activity within the star and a dust cloud, the researchers found. They captured a special picture that showed the star as a disk instead of just a dot. Since he became interested in Betelgeuse when he was 10 years old, Montarge has been studying it for a considerable amount of time. The photos showed a sizable dark patch in the star's lower left corner when viewed from the north. This region was mostly constant over time, suggesting that a dust cloud is to blame. Betelgeuse's surface experienced a tremendous explosion that produced this cloud of dust. Although stars release matter on a regular basis, Betelgeuse's outburst was extraordinarily massive, releasing a far greater volume of material than our Sun does. The piece that was ejected was probably heavier than the Moon several times over. According to scientific speculation, the explosion was caused by a gas bubble inside the star. The star has regular cycles, with similar events occurring about every 400 days. The precise reason for this explosion is yet unknown, though. In order to track Betelgeuse's future activity, scientists continue to observe it. This may be an unusual yet widespread phenomenon in the universe. Its visibility is a result of our in-depth understanding of Betelgeuse, its close vicinity to us, its size, and our use of a powerful telescope. Researchers have determined that Betelgeuse's decreasing brightness was brought on by a dust cloud that originated from the star and obscured its southern portion. There are mysteries concealed throughout the vastness of the universe just waiting to be discovered. Betelgeuse is one of the innumerable stars that grace our night sky, and it has fascinated astronomers and stargazers for millennia. Betelgeuse, the glorious crimson behemoth often referred to as the shoulder of Orion, has captivated us with its immense magnitude and flaming splendor. However, there is something unusual occurring in the depths of space, a cosmic event of epic proportions that is shocking scientists to no end. The James Webb Space Telescope has discovered a startling increase in Betelgeuse's brightness. The scientific community has been captivated by a startling 250% rise in brightness, prompting numerous inquiries over the nature of this celestial phenomena. What might be causing this unexpected spike? And is Betelgeuse about to explode like a supernova? Everything we believe to be true about the star's life cycle is called into question by the astounding increase in brightness. Come along with us as we set out on a fascinating journey to solve the mystery surrounding Betelgeuse's unexpected 250% brightness spike. The brilliant star Betelgeuse has recently gotten much brighter. You've undoubtedly noticed this reddish shining on the shoulder of the Orion constellation, which is particularly popular at the moment, even if you don't know its name. Betelgeuse is a really big place. To put it in perspective, its outer surface would reach past Jupiter's orbit if it were at the center of our solar system. Unlike other stars, this massive star is plainly seen and varies noticeably, which is why it continues to draw our attention. Because this Orion is so near our galaxy, its shoulder brightness varies, sometimes considerably. Because Betelgeuse is a semi-regular variable star, its brightness varies as it gets closer to the inevitable supernova explosion that would cause it to collapse grandly. This star, which was initially very noticeable, has been much more exciting in recent years because of sudden variations in brightness that scientists are still learning more about. The Great Dimming, which we'll talk about later, in 2020 marked the beginning of these changes. This causes the nearest red giant star to Earth to pulsate twice as quickly as it did previously, illuminating the southern hemisphere's evening sky with a vivid glow. Scientists examining the last phases of stars can learn a lot from this unusual behavior of one of the brightest stars. Betelgeuse is a supergiant star that fluctuates rapidly between brightness and dimness. On occasion, it has been observed to be more than 50% brighter than it usually is. A Betelgeuse Twitter account revealed some fascinating news on May 20th, 2023. The brightness of Betelgeuse has increased by an astounding 142%, according to their report. Subsequent reports even revealed a 150% increase. The supergiant star has risen significantly from its typical position at number 10 to 7th brightness in the night sky, according to astronomer Andrea Dupree of the Harvard-Smithsonian Center for Astrophysics. Look for it on the shoulder of the Orion constellation in the early evening to see it blazing brilliantly if you're in the southern hemisphere. You will also be able to witness it as the days become shorter in the northern hemisphere. Astrophysicist Dr. Sarah Webb of Swinburne University of Technology in Australia says that Betelgeuse offers a rare opportunity to observe the last phases of a huge star's life. We can discover more about what happens to red giants before they burst into supernovae by keeping a close eye on the star. When Betelgeuse finally erupts, it may become extraordinarily bright even during the day for almost a week, and it might even throw shadows at night. Both professional astronomers and amateur stargazers are excited about this spectacular occurrence. The impending supernova of the supergiant star is only 650 light-years away, and everyone is looking forward to it since it will provide us an amazing view of this amazing cosmic explosion. Betelgeuse is very interesting to people, says Heidi Morris, a scientist at Los Alamos National Laboratory and head of the Pajarito Astronomers and Astronomy Club. For a very long time, this star has been going through cycles of getting brighter and then dimmer. Thousands of years ago, Aboriginal Australians and ancient Greeks both noticed the pattern of shifting brightness. Betelgeuse's brightness cycle typically lasts 400 days, but as of late, it has been shifting somewhat more quickly, roughly every 130 days. This peculiar behavior was seen by researcher Andrea Dupree, who is studying the star. This variation in brightness is not characteristic of Betelgeuse. It started in 2019 when a portion of the star's outer atmosphere was released. Whether these alterations portend a future supernova event is questionable. We are unfamiliar with this circumstance and uncertain about the result. Dupree estimates that it will take another 5 to 10 years for the star to return to its typical brightness cycle, as do experts from Harvard and the University of California, Berkeley. Additionally, they see that the star's velocity and brightness have changed after the dimming incident. Betelgeuse is a massive red supergiant star that is only 10 million years old, far younger than our Sun, which is 5 billion years old. It's nearing the end of its swift transformation. Its core will collapse under its own weight when the fuel runs out, resulting in a massive explosion that might outshine entire galaxies in brightness. It's certain that this will occur, but we're not sure when. Or Grauer, an associate professor of supernova research at the University of Portsmouth, believes that we are unable to forecast the exact time of explosion. Therefore, we are unsure of the star's supernova date. Seeing as how few supernovae there have been in history for us to study, it is hardly surprising that very few people alive now will witness the explosion of Betelgeuse. The star has a lot of internal modifications to go through before it blows supernova. It converts helium into carbon and other elements like oxygen and iron in its role as a red giant star. Thousands of years pass during this procedure. The star will eventually run out of fusion reactions and collapse under its own weight. Either a neutron star or a black hole will form from it. In its core, this supergiant star is presently fusing carbon with helium, but we are unable to view inside the star. According to Flatiron Institute astronomer Jared Goldberg, Betelgeuse will blow up, but it might take another 10,000 to 100,000 years. Because he is conservative, Goldberg wouldn't stake his career on a quick boom. Betelgeuse has been increasing redder over the past 2,000 years, according to historical records, which suggests it won't blow up anytime soon. Astronomer and star expert Jason Ibarra outlines this fascinating finding. Therefore, given that Betelgeuse recently changed into a red supergiant, we might have to wait a while for its explosion. According to NASA, Betelgeuse won't blow up for another 100,000 years. According to Heidi Morris, we should be aware of scientific developments and not assume that things will remain unchanged in 10,000 years. Dr. Sarah Webb reminds us that even if it's extremely unlikely that we will see the explosion, we should still have hope. This occurred as a result of the star's atmosphere being chilled by an exceptionally cool convective cell, which turned expelled gas into dust and obscured the star's light. To verify this idea, scientists employed simulations and imaging analysis of the star. According to the modeling, both things happened at the same time. Typically, one of the brightest stars in the night sky is Betelgeuse. It was known to astronomers that it dims periodically, shedding almost 25% of its maximum brightness every 425 days. They were taken aback, nevertheless, when its brightness unexpectedly decreased by 2/3, making it visible even without a telescope. The star went through a big outburst in 2019 that blew off a large section of its visible surface. This was the primary cause of the dimming and resulted in a huge ejection of surface mass, which is exceedingly rare for a normal star. About 400 billion times more gas and dust were released than would normally be seen in a coronal mass ejection. Scientists explain this phenomenon with an analogy. They liken it to tossing away our arms. Just as losing a limb would alter our gait, Betelgeuse's mass expulsion upset its internal forces. A tumultuous mixture of magnetic and plasma fields resulted from this. The star may be brighter than expected at this point in its 400-day cycle due to turbulence. This incident has caused anomalous behavior, such as oscillations or bouncing, while the star's stability and core are still healing. These findings shed light on how red stars lose mass prior to exploding into supernovae. But Betelgeuse's latest actions don't necessarily indicate that an explosion is imminent. Astrophysicist Andrea Dupree used information from NASA's Stereo A, the Hubble Space Telescope, and other observatories to examine Betelgeuse's activity both before and after the explosion. Understanding the tremendous ejection of mass from the star's surface was made possible by data from the Hubble telescope. The never-before-seen occurrence gave astronomers a real-time view of the star's surface features and evolution. The 2019 outburst was caused by an extremely massive convective plume that broke the star's regular pulsation cycle. Betelgeuse's surface continues to move while it regenerates, even after its outer layers have returned to normal. Similar to an unsteady washing machine, while little portions of our sun's outer layer are occasionally released, it is unusual to witness such a large chunk being blasted from the surface of a star. For thousands of years, mankind have been fascinated by Betelgeuse. It was dubbed Orion's troubled star by the ancient Roman poet Horace more than 2,000 years ago. Because it is near Earth and brilliant, scientists examine it. It plays a significant role in numerous myths and tales. People in antiquity were aware of Betelgeuse. Betelgeuse and other variable brightness stars have long been studied. Stars like Algol and Omicron Perseus underwent changes that the ancient Egyptians saw. While Greek mythology associates Betelgeuse with the constellation Orion, the ancient Egyptians placed it in the constellation Osiris, which was named for their deity of the underworld. The star may not have always been red like it is now. The Arabic term Yad al-Jawza, which means the giant's shoulder, is where the name Betelgeuse originates. Its color was described as hypokairos by the Greek astronomer Claudius Ptolemy, which might imply reddish-pink or pale yellow. This implies that the color of the star may have evolved throughout time. Even before Western scientists, Aboriginal Australians were aware of Betelgeuse's bright and faint cycles. They may have been the first civilization to notice these cycles because they have been doing it for more than 65,000 years. Oral histories and cultural artifacts demonstrate their comprehension of stars with variable luminosities. 3 red giant stars, including Betelgeuse, were mentioned in South Australian Aboriginal traditions, according to research. These customs have been documented since colonization, contradicting our preconceived notions and offering insightful perspectives on the development of astronomy. It also draws attention to the remarkable, yet frequently underappreciated, observational abilities of Aboriginal Australians. Astronomical occurrences such as comets passing by, stars rising, eclipses, auroral displays, and meteorite impacts are all covered in Aboriginal traditions. These traditions place a great deal of significance on reddish celestial objects, which may account for the prominence of these stars. The belief held by Aristotle, the Greek philosopher, that stars were fixed and unchangeable lasted for over 2 millennia in Western science. This theory was refuted in 1596, however, when German astronomer David Fabricius found that the star Mira in the Cetus constellation had variable brightness. Though subsequent research has shown that Rigel is the brightest star in Orion, Johann Bayer called the star Alpha Orionis in 1603, believing it to be the brightest star in the constellation. Alpha Orionis is the current name. Astronomer John Herschel noticed in the 1830s that, in contrast to other stars, it would occasionally look brighter and other times darker. Astrophysics is a specific subject that studies how stars change in properties as a result of this discovery. Currently categorized as a semi-regular variable star, Betelgeuse has a cycle of almost 5 years as opposed to the typical 400-day cycle. Even after centuries of study, humans still don't know a great deal about this star. It indicates there is still more to learn about. The universe. In the grand scheme of things, Betelgeuse is but a tiny detail. We are at the cusp of a new age in the exploration of the wonders of the cosmos because scientists and visionaries have propelled us far into space. We appreciate your interest in space theory, and while you are here, please click the video to view more excellent information.